大家好. My name is Stéphane SIREAU, and I'm Vice President of High-Tech Industry at Dassault Systems. It's humbling to be here in the land of high-tech, Taiwan. I'm here, I have so much to learn from you, and today I would like to share what we mean by a virtual twin in high-tech for Dassault Systems. I'd like to take you through a journey with very concrete examples of virtual twins throughout the high-tech industry and really show you the diversity of what we do at Dassault Systems in the field of high-tech. So, put quite simply, the virtual twins that you can build with our solutions, well, it all starts with chips. And I will spend some time going through our solutions and what we do for the semiconductor industry. And on the basis of these chips, we are able, through our solutions, to design the virtual twins of connected systems, of those electronic devices that you use in industry or which you use as consumers, consumer electronics. And the final focus I will take today is take you through the work that we do through virtual twins of the digital infrastructure that powers this world of high-tech. I'm talking here of data centers, that Mike so expertly demonstrated a moment ago, and networks. We often talk about AI, but there's so much happening also in the field of networks with 5G, and in a few years' time, 6G. This journey at Dassault Systems, we do not do it alone, we do it with our customers. In fact, we like to partner with the most advanced customers so that we can learn both ways. And I think, if anything, that was the takeaway from Mike Young's presentation of our partnership between QCT and Dassault Systems. It's partnering so that we both learn, so that we bring the real and the virtual worlds together, and so that effectively we build the future of a high-tech which is sustainable, which is bringing wonderful experiences to consumers. We have, within the customers that you can see here, a number of strategic partners. I mentioned QCT, but also Ericsson, also ST Microelectronics, and so many more with which we deeply partner to bring forward new experiences. And so today I'd like to start with what we do in the field of connected systems. So I'm often told, well, we live in a world of digital, of IoT. We all have 10, 20 connected devices at home. And I just want to remind everyone, no doubt you already know this, but this is just the beginning. It is time 3 that we're going to see in the next years in terms of connected systems that we all use in industry and as consumers. Not just that, but the complexity of the interactions between these connected systems will increase. They will increasingly become autonomous, AI-powered, and agents able to interact with their environment. So at Dassault Systems, we continue to invest in this space. And we invest with a single clear purpose. It is that of our platform, the 3D Experience platform. You should all be familiar with this, but it goes without saying that this, for us, is the North Star of what we do at Dassault Systems. It is a very simple concept that a virtual twin of any device should be put in motion through a digital asset, which is a model, and that every device should have its model, and that every model could be simulated, which is what you see here, V plus R on the south side of this planet here, that you should have real-time data about this model, which is what you can see here on the east side, and that you should have the ability to interact with this model collaboratively through your tens, hundreds, thousands of engineers and workers, which is here the North Star collaboration. And so within high-tech, we take this at heart to say, okay, let's make this adaptable and focused specifically in the world of high-tech. And how do we do this? We do this, first of all, by having a platform which is open for the mechanical engineering. You know CATIA, you know SolidWorks, but our platform is open to many other solutions, whether it's Creo, whether it's NX, the ability that the platform should be open to other solutions. We take that openness on the electronic side with partnerships with ECAD vendors. I'll go back to it in a moment. But effectively, the ability to integrate ECAD within the design of your high-tech products. And finally, when it comes to simulation, the ability to do a multidiscipline simulation, whether it's EMAG, whether it's thermal, whether it's structural, and bring this all together always through this eye of a model, which is system-defined. And we believe this is important for you, because as electronics becomes much more complex and interacts in a much more complex way and becomes increasingly AI-powered, the complexity of these products require a model. They can't require doing one-off prototypes or just building through files and sending them around. They require a model. So the long-term view that we have remains very clear-headed. It's an AI-powered virtual twin. AI-powered virtual twin. I mentioned the ECAD players that we work with effectively. We take a lot of care of building these relationships with these ECAD players. You can see here the latest updates that we cover with them. It also takes place of a strategic partnerships that we have with Cadence Design Systems, which I'm sure many of you are working. And the work we're doing with Cadence is truly exciting. We are building this model-based approach so that you can semantically integrate your Cadence PCB model within the design of your electronics, so that you're really working out of a single model, including the mechanical and the electronic components of that. Now, if there's one thing which is essential in Taiwan, it's exporting to the world, and recognizing that we are putting a lot of emphasis on something which is becoming increasingly important throughout the world. Myself, I am European, and the European Commission is strongly driving a lot of sustainability regulations. There's a regulation coming, for example, for a digital product passport that should follow a product throughout its life. And so at Dassault Systems, we have put sustainability at the core of what we do. If I show you here just this video, we have embedded within CATIA the ability to be able to see the carbon footprint and other sustainability indicators, such as the water footprint of your design. This seems pretty anodyne, but when you think about it, when you're building a product, you should be able to see not just its features and its functionalities, but its sustainability footprint. And so effectively, by really putting sustainability at this core, we are releasing on a very regular stream new capabilities for you to be able to design sustainable products, recyclable products, and therefore being able to address all these markets and meet customer needs, because customers increasingly are asking for circular products. So, all in all, what it looks like, you can see through these videos, is a collaborative platform. It's a platform where you can work together, all your engineers can work together, working out of a single model in a way which is sovereign, where each user effectively has the access rights he needs to the right information for engineering all the way to manufacturing. The ability to design a virtual twin inclusive of electronics, as you can see there. And finally, a unified governance which allows to take you throughout your supply chain, throughout your bill of materials, from engineering down to manufacturing, inclusive of components. And and my team, is heads down focusing to continue down this route of giving you the best tools to build the best high-tech experiences, the best sustainable experiences for your customers. Now, beyond what we showed here, we discussed briefly artificial intelligence. And artificial intelligence here is at the core of our focus. We are investing heads down. The idea that we have as Samson mentioned, is that any engineer will be augmented. His productivity will be massively augmented by AI. And that AI will not just effectively allow him to be more productive, but that, and this is a topic I have heard from many of the Taiwanese companies I've talked to, leverage and bring together the knowledge of know-how of decades of engineering that you have, and revealing that knowledge and know-how is not easy. And it takes a platform, and that is what we're working out with Dassault Systems. In this second middle video here, you can see, for example, how we're doing semantic clustering of the knowledge and know-how of all the subcomponents. In this case, it's a car, not an electronic product, but it's really capturing that semantic knowledge base and revealing it so that your engineers are able to capture decades of information from hundreds or even more suppliers and reveal it. And the approach we take to AI is on the knowledge I mentioned. It's also working on the latest models. We talk a lot about LLMs. You can see on the first video, really working to be able to integrate language discourse in how you interact with all the information and knowledge and know-how you might have as a company. For example, around regulation and compliance with regulation. And on the third video, it's also applying, and this I think is very important, our scientific approach to be able to generate. So it's generative design. Generative design is something where you want to generate in a way which is traceable, scientifically based, the right model to be able to meet the right needs. In this case, you can see it's a metal casting piece. AI at its heart, focusing on sustainable experiences. We then, at Dassault Systems, look at data centers. So I won't dwell too long on this, because Mike did a fantastic presentation of what we're doing here. But we are effectively, through data centers, elevating our view of high tech, not just to the chip, to the server, but to the actual space, to the actual system itself that we're able to model with our solutions. And this today is absolutely crucial. First, the data center market is exploding. And even if you're not directly in this data center space, there's many chances that your components, that your devices are finding their way into this space, whether it's into the servers or whether it's into the cooling systems or others. And effectively, our approach here is to view the data center as a system and to be able to model it as a system. And the case that we saw with Mike was really about the thermal management of a server room, but we can go beyond that to do the management and the view of the data center as a complex system itself, from the chip to the server room, and to the data center within its environment, within its natural environment. If it's, for example, an earthquake-prone zone, or if you need access to specific sources of water, or if what might happen in the future, you need to connect it to nuclear power, for example. These are all things that we're able to model on a multi-scale level, from the chip to the overall system. And I mentioned this flying by, but if you have any questions about this, obviously the team here in Taiwan is available to take you through this, and we'd be very happy to show you all the breadth of what we do here. Networks. For all the talk of AI, the potential of 5G, what we've noticed, is still very much there. Many companies are aware of 5G, many industries realize there's potential, but all in all, when you look at the potential globally, it's about 15 million potential venues that could be powered with a 5G network, and which could also become their own operators of 5G networks. And I want to talk about this because it brings us to, and you can see in this illustration here, this is a tire company which is implementing a 5G network within its factory. And within Dassault Systems, we have solutions for manufacturing, as you know, whether it's the plant layout and the process definition of your factory, all the way to the manufacturing execution systems. But within that, we're able to create the virtual twin of the 5G network. And this is important, because it's not just about building high-tech products, it's about connecting them through what is, for the first time, an industrial-grade wireless network. As you know, 5G, it's about 40 times faster than 4G, and it's industrial grade. You can literally connect robots to 5G in a manner which is industrial grade. But when you do so, you're creating so many opportunities within your factories, which you can themselves configure for your virtual twin, but you want to make sure it works. For that, you need a virtual twin of the network, which you can see there, but you also need, what you could see a moment ago here, you need to go to the details of that network. In this case, we see there's an AGV, an automated vehicle, carrying a tire, and we're able to simulate the network around the tire, whether the AGV is carrying the tire or not. And this is a great example to say, if you're bringing 5G in a factory, you want to make sure that it works, and you need to simulate every detail of it. And for that, you need that virtual twin of the network. So with opportunity of the 5G networks, you want to minimize the risk of it actually not working, and that's where virtual twins allow to do this all virtually and get it right the first time. So this is also a topic which we're working on, leveraging our simulation and systems and our factory solutions, Delmia. We'd be very happy to go through this with you if you have any questions along the way. It's really taking high-tech through the digital infrastructure of high-tech. Finally, chips. Effectively, here, Taiwan, we're in the land of chips. It's humbling to be here. And this industry is growing formidably, as you know. And in fact, most, if not all of the most advanced chips are designed, or certainly manufactured, and increasingly designed here. We have been investing in this domain for several reasons. The first is we recognize the complexity, first of all, of a chip in itself, but the chip also within the system. So here what you can see is we take also a multi-scale approach to chip design. So we are not an EDA company per se, but we are a systems design company. So our capabilities are the design of a car, the design of an aircraft, the design of an electronic system, effectively, all of these which increasingly are being defined by the chips within them. And so through our systems capabilities and through our simulation capabilities, we are able to take each of the steps here and connect it from the system down to the chip, or in fact to the material, which we're able to model and simulate through our BioVia tools. So our approach to semiconductors is really this multi-scale approach, is to help our customers articulate their chip design in the context of a wider system. And all across the way, our brands are there to be able to give that particular visibility and design capabilities to really optimize the overall process. We've been in this scale for around 20 years. We are the practitioners of an IP management tool called Design Sync, which is used by many design companies across the world. And effectively, we are leveraging this really to build our chip design from chip to system. And we are also looking very deeply in the ability to model the manufacturing process of a chip. Here you can see some work we're doing with Purdue University. And what we've been looking with them is how do we model a clean room? How do we model and effectively simulate what's going on in the clean room? You might see here some particle simulation. You might see some airflow simulation. And we're working with some equipment manufacturers to be able to model and simulate some of the processes taking place in that clean room. Our view is that there is a need for virtualization in semiconductor manufacturing, which, as you know, is an extremely complex process with hundreds of steps, and that virtualization takes a new form of platform which allows the various actors in this space to be able to collaborate. This is the work we're doing with universities and with increasing number of players across the world. So, in conclusion, in semiconductors, our view and our impacts and our solutions are relevant in the design of chips within the context of systems and in the manufacturing of the chips as the example here that we can see with Purdue. So all in all, our portfolio really covers a multi-scale approach to high-tech, from the chip to the connected system to the digital infrastructure. And we take particular focus in a systems approach, is as these elements, these three elements are intricately linked, the system itself, designing a high-tech system, becomes increasingly complex and requires a system engineering approach which allows to navigate through that complexity. Taking a focus on the continuity, the traceability, and the collaboration between the teams. This is something that our Innovia brand has for decades focused on, is how do we bring a platform for collaboration? Because this is not a single person, or in fact a simple company, increasingly, that we will be able to address the design of these high-tech products. Sustainability is for us core. It's for us core. It's what consumers are asking. It's what increasingly regulation is asking. Bringing an open platform both on the mechanical side and on the electronics side. Finally, keeping a wider scope, not just on the electronic device, but within an infrastructure which includes networks, which includes data centers and compute. And finally, really focusing on AI, but focusing on an AI that makes sense for engineers, where they can base themselves on these AI tools to be empowered, to be much more productive with an AI which is traceable, which gives them the scientific base to be able to build the best products out there. I'll be here today and tomorrow. I'm delighted to meet you all. The whole team here in Taiwan is at your service to cover all of these topics, and I'd like to thank you once again for your time. Thank you.